Okay, so now I'm going to go ahead and go through the 3A portion of the final review packet. All right, so first off, whenever you're asked for the domain, what the domain is asking you to find is what values make the denominator equal to 0, okay? What can x not be, because we know we're not allowed to have a denominator of 0. So to find the domain, all you need to do is take the denominator before you cancel anything. So if you're asked to find the domain, you do this, you take your factored form before you cancel anything, and you set it equal to 0, and you solve. So I get x cannot be -5, and x cannot be 4. So my domain is just x cannot be -5, and x cannot be 4. That's it. Then the directions say simplify. So to simplify, all you do is you just cancel what's on top and bottom. And here I end up with x minus 5 over x minus 4. And that is my simplified version. All right. Now for multiplying. Multiplying is very, very similar to simplifying. So in this first problem we did here, the polynomials were factored on top and bottom already. As you can see, for this problem here, they are not factored, so we have to go through and factor them. So that's the first thing I would do. This one here is a difference of squares. So if you recall, we got to square root both of these and then do plus minus. So I end up with x plus 1, x minus 1. Factoring this guy, got to figure out what multiplies to this, adds to this. So I end up with, and this is like we could use the cheat method of factoring here. You could do AC if you like. You'll end up with the same answer. So we end up with x plus 1 and x plus 2. That multiplies to 2 and adds to 3. X plus 2 I can't factor. It's just like a binomial that can't be factored there. So we can leave it like that. And then we can go ahead, figure out what multiplies to this, adds to this. So I don't know why I changed the color. Let's see. So in this case, let's see, we get an x plus 2 and an x minus 1. All right. So now, before we cancel anything, so remember, whenever you're asked to find the domain, you have to find it before you cancel anything. We just have to take our denominators and set them equal to 0. Okay. So I look and I'm like, okay, well, I can say x plus 1. I get x cannot be -1. X plus 2 equals 0. I get that x cannot be -2. Obviously, this x plus 2 is duplicated. And we only have to check it once. We get, we get x cannot be equal to -2 twice. Here, we set this equal to 0, and we get that x cannot be equal to 1. All right. So that is our domain here, right? We'd say that x cannot be equal to -1, x cannot be equal to -2, and x cannot be equal to +1. Now, for simplifying, when you're multiplying, basically it's just like anything on the top can cancel with anything on the bottom. So this guy can cancel with this guy. This guy can cancel with this guy. And something that's very important is, let's say you have multiples of something, only one of them cancels, okay? So like this guy can cancel with this one, or can cancel with the other, but you're going to be left with one of those x plus 2's in the denominator. Now, as you can see, everything in the numerator went away, okay? When there's nothing left in the numerator, we have to put a 1 there, okay? Because we have to show that this x plus 2 is in the denominator. And if we don't put a 1 there and just put like x plus 2, it looks like it's in the numerator, which is wrong. All right. So that is our answer there. All right. Let's see. I'll do this one.
Still a student.
All right. Let's see. She's not here.
Not here?
Nope.
Perfect. Thank you.
All right. Okay. So this one is definitely like a tricky one. 3 minus x, when we factor that, what we actually want to do here is we're going to take out a negative. So think about like if we have 3 minus x and then I take out a negative, I get -3 plus x. Okay. That is equivalent to negative x minus 3. Okay? So these are equivalent expressions. Now, the reason I did this is when you have something like in this form where it's like a number minus x, generally what you want to do is take a negative out because there's probably a good possibility that this x minus 3 is going to cancel with something. So you have to pull that negative out to see if it cancels with anything. All right. So I'm going to go ahead and just factor the rest of everything here. Let's see. So I take out a GCF and I get x minus 3. Here is another, what do you call it? Difference of squares. So I get x plus 3, x minus 3. And then let's see, I'll leave it as division for right now. I get x cubed and then negative x minus 3. All right. Now, so now what we're going to do is we're going to find the domain. Okay. Now, finding the domain of a division problem, not only do you have to set the denominators equal to 0, because it's a division and we flip that second fraction, we also need to set the second numerator equal to 0. All right. So we end up setting, let's see, x plus 3 equal to 0. And then we have to do x minus 3 is equal to 0. Now this guy's repeated, so we only have to do him once, right? And then the negative doesn't do anything. That's like a -1, and you can't set -1 equal to 0. And then I say x cubed is equal to 0. So we get that x cannot be equal to -3. X cannot be equal to +3. And the way that you solve this, right, is you take the cube root. So we get that x cannot be equal to 0. So that is our domain. X cannot be equal to -3. X cannot be equal to 3, and x cannot be equal to 0. Now, because it is a division problem, what we're going to do is we're going to keep the first fraction the same. And this is where we do the keep, change, flip. So now we change this to multiplication, and we flip that second fraction. So let's see. I'll have this guy cancel with this guy. And then with these x's, this x cancels with one of these x's, right? So I have an x and then an x cubed in the denominator. That means that I'm going to be left with an x squared here. So now, let's see. In the numerator, I have left a negative x minus 3. And then in the denominator, I have an x squared and an x plus 3. So that would be my answer there. All right. So next we have our, what do you call it? Adding and subtracting. So these ones are definitely more challenging because we need a common denominator. So if let's try this one here. If we look here, first off, these denominators are already factored. If the denominators are not factored, you have to go and factor them. Okay. And looking here, it looks like my LCD is going to be 3 times x plus 1. Basically, you're like, okay, what does this guy have that this guy's missing? And you kind of combine them. All right. So my LCD is 3 times x plus 1. Oops, I thought I was erasing. So my first fraction here, I've got x plus 2 over 3. And he is missing the x plus 1. So I'm going to multiply him by x plus 1 over x plus 1. So I have to go ahead and FOIL out my numerator here. So I get x squared plus x plus 2x plus 2. And then the denominators, you don't necessarily have to multiply out. A lot of the times they don't multiply out the denominator, so you can just leave those factored. So this ends up becoming x squared plus 3x plus 2 all over my LCD of 3 times x plus 1. Now I'm going to go ahead and deal with this fraction. So I've got 2x all over x plus 1. And he's really close to having LCD. He just needs a 3. So I'm going to multiply the top and the bottom by 3. So I end up with 6x all over 3 times x plus 1. So at this point, I have x squared plus 3x plus 2 all over 3 times x plus 1. And then I have minus 6x all over 3 times x plus 1. So at this point, I have my common denominator. So I know my denominator is going to be 3 times x plus 1. And what I need to make sure that I do is distribute this negative to everything on top. Now, in this case, there's only one term, so it's not that big of a deal. But if there were multiple terms in the numerator there, you want to make sure that you distribute that to everything on top there. So at this point, I have x squared plus 3x plus 2 minus 6x. And now my last step is just combining those like terms on top. So I get x squared plus, oh, nope, I don't. X squared minus 3x plus 2, all over 3 times x plus 1. In theory, you could go ahead and like factor this again and see if anything cancels, like attempt to factor the numerator. But in this case, we'll leave it as is. We probably, let's see, can we factor that? It'd be x minus 2, x minus 1. Oh, that actually, well, nothing cancels though, so we're good. We can leave it like this. All right, so now let's go ahead. We will solve one of these rational equations here. Let's see, what would be, all right, we'll do this one. Okay, so first thing I would like to do here is I like to identify the LCD, right? So in this case, my LCD is going to be x plus 2 times x plus 4. And I know that I find my domain by taking my denominator and setting it equal to 0. So we'll go ahead and do that right away. So we do x plus 2 equals 0, x plus 4 equals 0. That means that x cannot be equal to negative 2, and x cannot be equal to negative 4. Now, in this case, this is actually going to be like important to us because we're solving. So let's say we solve this equation and we get negative 2 or negative 4 as an answer. Those are what we call extraneous solutions. They're bad solutions, so we would have to cross them out. Okay. All right, so now I'm going to work to get my common denominator here. So this first fraction, 3 over x plus 2, he needs the x plus 4. So I'm going to multiply him by x plus 4 over x plus 4. I get 3x plus 12 all over, whoops, x plus 2 times x plus 4. This one, I'm going to go ahead and multiply him by x plus 2, right? So I've got 5 over x plus 4, and he needs an x plus 2. So I get 5x plus 10 is equal to x plus 4, x plus 2. So at this point, I can go ahead and cross out my denominator. Once you get that LCD across the board, you can just get rid of it. And then solve the equation you got on top. So we've got 3x plus 12 is equal to 5x plus 10. I'm going to subtract 3x from both sides. I get 12 equals 2x plus 1. I subtract 1. And I get 11. I'm kind of running out of space, aren't I? 11 equals 2x. I divide by 2. And I get that x is equal to 11 halves. Of course, before I circle my answer and I'm confident in it, I need to go and check to see if it is one of my domain restrictions. It's not, so I'm good to go. There's a what? It's a 10. What did I do? Oh, let's see. What did I do? I didn't put the 0. Oh, it is a 10. Thank you, guys. Okay. I appreciate you letting me know. Let's see. So let's go back to this. We get what? 2. So now we got what? 2 equals 2x. Is that what y'all got? All right. Thank you. I appreciate it. 2 equals 2x. I divide by 2, and I get that x equals 1, which is also still good. So that is our answer there. All right. Let's go ahead and try and crank through one more here, okay? Let's see. Let's do, I don't know. We'll do this one, I guess. All right. So I look here, and I can see that this guy is not factored. So I definitely want to factor this denominator here. So I get 18 all over x plus 3, x minus 3. So at this point, I can go ahead and identify my least common denominator. So my LCD here is going to be x plus 3, x minus 3. To find my domain, I set my LCD equal to 0, and I get that x cannot be equal to negative 3, and x cannot be equal to positive 3. Now at this point, I have to go ahead and get my least common denominator across the board. So I'm going to go ahead. I'll take this first fraction, 2x over x plus 3. He is missing in x minus 3. So I'm going to go ahead and multiply him by that. So I get what? 2x squared minus 6x all over x plus 3, x minus 3. This fraction here is missing an x plus 3. I distribute this, and I get x squared plus 3x all over x minus 3, x plus 3. So at this point, what my equation looks like is this guy plus this guy is equal to, and then my last fraction there already has the LCD of x plus 3, x minus 3, so I don't need to do anything to him. So now that I've got my LCD across the board, I'm going to go ahead and just cross it out and solve the equation on top. Now, one thing I want to point out, like that's going to matter on 42, make sure if there's a minus, you distribute it to everything on top because you're going to have like multiple terms on this number 42 here. Here, it's just a plus sign, right? You could distribute the plus sign if you want. It doesn't like change anything. But if it's a minus, you got to make sure you distribute that to everything on top. So here I get 2x squared minus 6x plus x squared plus 3x is equal to 18. So now I'm going to combine like terms that are on the same side here. So I get 3x squared minus 3x is equal to 18. Now this is a quadratic. The way that we solve quadratics is we get them set equal to 0 and we factor, generally I should say. So looking at this, there actually is a GCF we can take out. So I'm going to take out a GCF of 3. And then at this point, I just got to see, okay, what multiplies to this and adds to this. So I end up with an x minus 3 and an x plus 2. And then I just set my factors equal to 0. Now, 3 is just a number. If there was an x on the 3, I could like set it equal to 0 and solve. But like just the number 3, I can't make equal to 0, right? So that doesn't like help me at all in terms of solving. But I could do x minus 3 equals 0, and I get that x is equal to 3. I do x plus 2 is equal to 0, and I get x is equal to negative 2. Now, before I go and say, okay, these are both good answers, what I need to do is check to see if they are either of them are part of my domain restriction. And we already said that x cannot be equal to 3, right? So this is a bad solution, and my only good solution is negative 2.